When you think of an emergency room triage, you probably picture the flashing lights, right? The frantic shouting, the beeping
Oh,
monitors.
absolutely. It's a highly sensory environment.
Yeah, there's a very visible, very loud protocol in place. You see the signs of a crash immediately.
Right, because the distress signals are overt. The interventions are immediate and dramatic. I mean, we just expect emergencies to announce themselves with a certain level of volume.
But then you look at a forgotten windowsill in the corner of a kitchen or like a neglected plastic tray on a back porch, and you don't hear any sirens.
No sirens at all.
Right. It is completely silent, yet there is a literal life or death struggle happening right there in the potting soil. So welcome to today's deep dive. We are thrilled you are joining us because today we are heading straight into that silent emergency room.
It's a fascinating place to look.
It really is, and we have a highly specific, honestly fascinating piece of source material to guide us today. It's a personal journal entry from an author named Eng, published on April 22, 2026.
Right, titled Notes on Gardening Part 873.
Yeah, exactly. Notes on Gardening Part 873, Salvaging My Leggy Basil Seedling. And the mission of this deep dive is to explore the anatomy of a struggling plant and the exact hands-on mechanics of how to save it, using this neglected basil as our perfect case study.
And, while it might seem like a simple gardening update, this text is actually packed with sharp observational data.
It really is.
It covers biological distress, environmental factors, and the somewhat counterintuitive physical interventions required to reverse severe damage. Because we so often misinterpret the symptoms of distress when we don't understand the underlying biology.
Okay, let's unpack this, because before we can understand the rescue mission, we really have to look at the exact conditions that caused the crisis in the first place.
With the environment, yeah.
Right, and it starts with the origin of these seeds. Eng notes that these basil seedlings were sprouted from, quote, grocery store spice seeds.
Just off the shelf.
Literally just basic grocery store seeds. And then they were neglected. They were left to grow in the tight compartments of a seedling tray with, I think it was about 5 to 10 seedlings crammed into each little cell.
Crammed in there, yeah.
Plus, they were dealing with limited sunlight and a rainy season. But I just want to pause right there. We are talking about basic grocery store spice seeds. How does something that every day even manage to germinate and survive those tough initial conditions?
It's a great question.
Because we usually think of seeds needing these pristine, temperature-controlled nursery environments to do anything at all.
What's fascinating here is that it highlights the sheer, stubborn drive of biological life.
Just the will to live.
Exactly. A grocery store seed isn't necessarily bred for optimal garden germination, right? It is often processed and packaged for culinary use. It might be old, it might have been stored poorly.
Sitting in a warehouse for months.
Exactly. Yet the imperative to grow is completely encoded into its DNA.
Yeah.
When you introduce moisture and warmth, even in a cramped plastic cell on a neglected porch, that biological programming just fires up.
It just goes.
It has one job, and it attempts to do it regardless of the environment. But, Eng uses a very specific word to describe what happened next. And that word is microclimate.
Right, and usually when we hear about a climate, we think of massive geographic weather patterns, like a monsoon season or, a drought in the Midwest.
Right, big scale.
We don't usually think of a tiny plastic tray.
Well, microclimate is just a highly localized set of environmental conditions that differ significantly from the surrounding area.
Right.
Eng didn't just have a weather problem with the rainy season.
Right, it was more localized.
Eng accidentally created a hostile, localized ecosystem. Let's break down the physics of that small space. You have a plastic cell, maybe an inch or two across, meant for a single plant. Right. When you pack 5 to 10 seedlings into that space, you alter everything. You fundamentally change the humidity, the temperature, and the light availability right at the soil level.
Kind of like an overpacked elevator, right, where everyone is just desperately stretching just to get a breath of fresh air.
That is a perfect analogy.
So is the microclimate happening because the plants themselves are acting as a physical barrier?
Exactly. The ambient rain keeps the soil perpetually wet, sure, but the dense crowding of those emerging stems and tiny leaves creates a literal dome over the soil.
Oh, wow.
Yeah, it traps the moisture, preventing evaporation. It completely restricts airflow. And crucially, those competing seedlings block whatever weak indirect sunlight is actually making it through the rainy weather.
So the physical tray itself becomes its own weird, hyper-competitive jungle canopy on a miniature scale.
It does, and that specific microclimate triggers a desperate biological reaction in the seedlings.
They start panicking.
Basically, yeah, they're receiving a loud, clear signal from their environment that says, you are buried in shadow, the humidity is stifling, and you are surrounded by competitors. This forces the plant to abandon its normal growth strategy and shift into pure survival mode.
So the plant is sending out these silent SOS signals because of the microclimate, but what does that panic actually look like above the soil?
Well, Eng diagnoses it perfectly.
Right. Because of this accidental ecosystem, the plants develop physical symptoms, which Ang sees before taking action. Ang uses the term leggy.
Leggy, yeah, that's the industry term.
And the visible symptoms of a leggy seedling, according to the journal entry, are these elongated stems and very few leaves. And some of these seedlings only possess a single pair of what Ang calls true leaves, and they look quite pale.
The paleness is the critical diagnostic detail here.
Here's where it gets really interesting for me, and I have to challenge this assumption. If you ask me, or probably most people listening to this deep dive, we associate a plant growing really fast and getting really tall with robust health.
You think so?
Right. You want your plants to shoot up. You want them to grow. Why, in this specific case, is being tall actually a massive red flag?
Because it is a complete misdirection. Above the soil, you see rapid vertical growth, but you have to look at the economy of the plant.
The economy, like its energy budget.
Exactly. A seedling operates on a strict, finite energy budget. It only has so much stored energy from the seed to establish itself before it needs to start generating its own power.
From photosynthesis.
Right. When Ang observes that the stems are incredibly elongated, but there are very few leaves, and that those leaves are pale, we're looking at a plant that is entirely misallocating its resources.
Misallocating how? I mean, where is all that energy going, if not into being healthy?
It is spending its vital, limited reserves stretching its cellular structure. The botanical term is elongating its internodes, the spaces between where leaves would normally grow.
Oh, great.
It is doing this in a frantic reach for whatever weak sunlight is available above that crowded canopy. In doing so, it completely abandons the development of its foliage.
Because it just doesn't have the bandwidth to do both. Like, it can't build a tall stem and build big leaves at the same time.
It is an either-or scenario for a stressed seedling. Leaves are the solar panels of a plant. They are how the plant photosynthesizes and creates long-term energy. If it doesn't invest in leaves, it has no future.
Wow.
And the paleness Ang notes is a direct result of this. Paleness indicates a lack of chlorophyll, the green pigment responsible for capturing light energy.
So it's starving.
The plant is literally starving itself of its own food production mechanism just to win a foot race to the top of the canopy.
So the tallness isn't a sign of strength at all. It's a sign of panic. It is sacrificing its long-term survival just to get a breath of fresh air in that crowded elevator we talked about.
Precisely.
And you always have to wonder what's going on beneath the surface when you see that kind of panic. The text says Ang actually confirms the underlying issue when transplanting them. The journal reads, the roots were short and sparse.
Short and sparse.
It makes sense, right? If it's spending all its money on a tall stem, the roots are going to suffer.
The visible symptoms above ground always reflect a hidden reality below ground. The roots are the supply lines and the structural foundation. When you cram 5 to 10 seedlings into a single cell, there simply is no physical room for the roots to expand.
They're just trapped.
They hit a plastic wall immediately and tangle with each other, competing for the same limited drops of water and nutrients.
And even if they had the room, the plant isn't sending any resources down there anyway.
Correct. The plant is directing all hormonal and energetic traffic upward to find light, so the roots remain stunted. But think about the physics of what the plant has just built.
Okay.
It has constructed a tall, elongated, top-heavy stem that requires massive amounts of water and nutrients to stay rigid. But it only has short, sparse roots that cannot possibly absorb the required volume of nutrients from the soil. The architecture is totally unsustainable.
It's like realizing the builders constructed a 50-story skyscraper but completely forgot to pour a concrete foundation.
That's exactly it.
It's just resting on the dirt, ready to topple over. It really makes you evaluate the things you might be building in your own life or work, you know? Sometimes we push for that rapid, visible, vertical growth, completely ignoring that our foundation is totally sparse and shallow.
It is a common misdiagnosis, both in horticulture and, well, in project management. We see upward movement and we assume stability. Ang's ability to look at pale leaves and deduce a hidden root deficiency is the absolute prerequisite for applying the correct solution.
Right, because otherwise you're just treating the symptoms.
Without that correct diagnosis, any intervention is just guesswork.
So what does this all mean? The diagnosis is in, the patient is critical, the long stem is a liability, the leaves are starving, and the roots are virtually non-existent.
That's a bad situation.
Now we move to the rescue strategy, and this is where we get into the literal hands-on mechanics of the intervention. Ang writes, the usual approach for handling leggy seedlings is to transplant them into larger, deeper pots. I'll bury 3/4 of the stem and give them adequate space to grow.
This is where observation transitions into a highly specific corrective strategy.
But wait, my instinct here is that this shouldn't work. I mean, it's like literally burying your past mistakes to build a stronger foundation. But if you take a soft green stem that evolved specifically to be above ground in the air and the light, and you bury 3/4 of it deep into wet, dark dirt, shouldn't it just rot?
You would certainly think so.
How does a stem suddenly know how to survive underground? And more importantly, how does burying the majority of the stem directly solve the problem of the short, sparse roots we just mentioned?
If we connect this to the bigger picture, it is a completely logical pushback you're having. You would think that putting wet soil against a delicate above-ground stem would invite fungal disease and rot.
Exactly.
But with certain resilient types of plants like basil or tomatoes, you are exploiting a fascinating biological loophole. Along that elongated stem, the plant retains a latent, hidden capability to generate what are called adventitious roots.
Adventitious roots. Wait, what triggers that? How does the stem physically change its function?
It comes down to a cellular transformation triggered by the new environment. The stem contains undifferentiated cells that can change their purpose based on hormonal signals.
Like stem cells in humans.
Very similar concept, yeah. When Ang takes that tall stem and submerges it in dark, moist soil, the plant recognizes the environmental shift. The darkness and the moisture cause a plant hormone called auxin to accumulate in that buried stem tissue.
Auxin, okay.
And this hormone signals the cells to stop functioning as structural support for the air and to transition into root tissue.
Oh, wow. So the plant actually reprograms its own cells on the fly.
It does. By burying 3/4 of the stem, Ang is forcefully correcting both of the major deficiencies diagnosed earlier simultaneously. First, by moving them to larger, deeper pots, Ang is curing the space deficiency.
Right.
There is no longer competition from 5 to 10 other seedlings. Physical constraints are gone.
The elevator doors have finally opened and everyone can spread their arms.
Yes. And second, the plant converts that excessively long stem, which was previously its biggest liability, into a massive new asset. It will begin to sprout a dense, secondary network of roots all along that buried section.
Okay, let me go back to my skyscraper analogy. So to fix this tipping skyscraper, you aren't just trying to jack it up and pour a little concrete underneath the ground floor.
No.
You're literally pouring concrete into the first 30 floors of the building, turning the entire bottom half of the skyscraper into a massive, deep, expanded basement.
That perfectly captures the mechanics of what is happening. You are converting above-ground architecture into below-ground anchoring. Ang is taking the symptom of the stress, the overextended stem, and using it as the very mechanism for recovery.
Yeah, it's brilliant.
With a deep, robust root system now forming along the entire length of that buried stem, the plant can finally gather the sheer volume of water and nutrients it needs to push out healthy, dark green, true leaves. It is complete biological and structural reset.
And the plant physically needs that depth just to stay upright anyway, right? Because if Ang had just moved the plant to a wider pot to fix the crowding, but left that long, weak stem exposed above the soil, it wouldn't survive.
It would have collapsed under its own weight the moment it tried to grow heavier leaves, or it would have just snapped in the first breeze. The deep transplanting is the structural intervention that makes the biological recovery possible.
You have to support it.
Exactly. You have to provide the mechanical support while the plant goes through the energy-intensive process of growing a whole new root system.
It makes me appreciate how much hard logic and physics goes into a seemingly simple gardening task. You aren't just moving dirt around to make it look prettier, you know. You are performing structural engineering on a living organism.
You really are.
It's a perfect loop of cause, effect, and intervention. The microclimate creates the leggy stem. The leggy stem pulls all the energy from the roots, leaving them sparse, and the solution is to actually use that leggy stem to create new roots in a wider space.
And it all stems from Ang's initial observation. Ang didn't just look at the plant and say, "It looks bad, let me throw it away."
Right.
Ang looked at the pale leaves, understood the energy budget of the plant, and deduced the invisible root deficiency.
Let's bring this all together for everyone listening because there are some massive, highly applicable takeaways here from Eng's notes on gardening, whether you are dealing with a basil plant, a work project, or honestly a personal goal.
Absolutely.
First, we explored how an accidental microclimate born from severe overcrowding and limited light can completely alter the trajectory of a living thing. It forces the organism into a panic, prioritizing immediate frantic upward growth while completely neglecting its foundational root system.
And secondly, we learned that what looks like rapid progress can actually be a symptom of severe distress.
That tall stem.
Exactly. The vertical height was a facade, a structural liability hiding the short, sparse roots below the surface. A total misallocation of vital resources.
Right. And finally, we saw the mechanics of the rescue strategy, the physics of deep transplanting. By taking that leggy seedling, moving it to a spacious pot, and burying 3/4 of its stem, you aren't just hiding a mistake under the dirt.
Far from it.
You are exploiting a biological loophole, fundamentally changing the structure of the plant and giving it the literal room and hormonal cues it needs to transform its greatest weakness into a massive anchoring foundation.
Because diagnosing a problem, deeply connecting the visible symptoms you see above ground to the invisible realities below ground, is the only way to formulate an effective structural solution.
It really is. And as we wrap up this deep dive, I want to leave you with a final thought to mull over today, something that builds on Eng's incredible field notes.
It's a great note to end on.
At the very end of the entry, Eng writes, "Let's see how this unfolds in the coming days. It is open-ended, it is hopeful, but it is ultimately an experiment. I want you to consider the incredible latent resilience locked inside a simple, everyday grocery store spice seed.
It is a profound mechanism to consider.
Think about the journey of this specific organism. It was not given a pristine start in life. It was thoroughly neglected. It was crammed into a tiny claustrophobic space, starved of adequate light, trapped in a hostile microclimate, left to develop stunted, sparse roots, and forced to bankrupt its own energy reserves just to survive the initial few weeks of its life.
It's a tough start.
By all logical accounts, it should be a total loss. But it possesses this hidden mechanism, this dormant ability to be entirely salvaged and rebuilt. It just needed to be given a deeper foundation and a little bit of physical space.
It really speaks to the remarkable adaptability of life when finally provided with the right conditions, even after a period of severe compounding trauma.
So, the next time you are looking at a situation in your own life, maybe a project that has grown entirely in the wrong direction, or a scenario where you feel like you've been stretching frantically just to keep your head above the canopy while your foundation is crumbling, remember Eng's basil.
Good advice.
Remember that what looks like an irreversible, top-heavy mistake might actually just be the raw material for a much deeper, stronger foundation. You just have to know how to interpret the real symptoms, and you have to know how to bury the stem. We hope this deep dive gave you some new analytical tools for your own diagnostic toolkit. Thanks for joining us.